We are Team RDSI and our project is Crisis Data Relay. Our technical director is Bruce Torman. Our team consists of myself, Jonathan Pollard, and Matt Cordero. RDSI is a service-disabled, veteran-owned small business that performs a wide range of engineering, technical, and programmatic functions and support various government and commercial clients and specializes in delivering affordable, scaled, state-of-the-art solutions to government and industry clientele. The RDSI Department of Defense portfolio includes expertise in the areas of submarine imaging, electronic warfare, weapons, acoustics, communication, antennas, special projects, and software development. The motivation behind this project is the lack of innovation in the incident management sector and the need for new technological devices to aid and expedite firefighter response time. If any incident occurs with a placard involved, the Emergency Response Guide, also known as the ERG, is needed. This is a large and difficult book to navigate quickly, which led to the motivation of this application. The anticipated best outcome for our project is to have a prototype application that can quickly display all the information associated to a placard based on the ID number, as well as making sure all the functionality needed is available to the end user. We were able to achieve the anticipated best outcome by making a mobile application that was able to automate the emergency response guide, which will allow faster first response time for any incident involving a placard. These are the key technical accomplishments that we made throughout the year, which we will explain in more detail shortly. The economic impact of this project is that it will be the first application to quickly aid firefighters for incidents that require the ERG, and it will establish RDSI as a reliable figure for application-based innovation, which in turn will open up more opportunities for the company. This block diagram shows the functionality of our application. It will obtain the placard ID number from either a photo or typed entry by the user and then search the database on the phone with this number. After this, it will display all the information associated to this placard from the ERG. The camera interface will allow the user to preview an image in live time as well as zoom in with the slider. The user then will be able to take a picture that will get stored on the device. This is all helped by the camera package in Flutter. For text recognition, all the text from the images is extracted with the help of the Google ML Kit package, which uses machine learning to extract text from an image. Then the ID number can get filtered out from the extracted text and be used later on to search the database. The ERG functionality is shown by the flowchart on this slide. This flowchart guides the user on how to navigate the ERG. This book is hundreds of pages long, and navigating this flowchart requires the user to bounce all around it while remembering and keeping track of various information needed for the next stages of the flowchart. This can be time-consuming and even confusing at times. Our application mimics this flowchart but completely automates it for the user to have seamless use for a fast response time. Based on the ID number given by the user, all the information needed is searched and displayed automatically. Any additional questions that the ERG would need from the user are asked only when needed, and to simplify this process, simple button options are given so no manual input is needed. From the ID number and querying the user when necessary, all the ERG functionality can be automated in our application. Our application starts out by asking the user to either take an image of the placard or manually enter the ID number. Once either is done, the application will have the ID number and be able to search the database to get the guide number associated to the placard. The guide number is used to gather the information from the orange pages in the database, which has the evacuation distances. If the material is highlighted green, then the user will be asked if the material is on fire. The answer to this question determines whether the green pages, which holds the isolation and protection distances, will be displayed first, or the orange pages. If the green pages denote to look at Table 3, then the user will be asked to select which mode of transportation was used, which is needed to display this placard's isolation and protection distances due to the fact that this, along with the placard ID number, is used to search the database. The last thing that could be displayed is if it is denoted that the chemical is water reactive, the hazardous gas that will be caused from adding water to this chemical will be displayed. On this slide is an example of the application running for one particular placard. Our prototype application completely automates the ERG and will allow for first responders to have a faster response time to any placard-related incident. Next, Matt will talk about the backend database.
Thank you, John. So I'm going to start off by talking a little bit about the database expansions that were made from fall semester to spring semester. So similar to what we saw last semester, on the right-hand side, we have a little code snippet and then a cutout of the emergency response guide, also known as the ERG. And we're seeing a direct translation to the ammonia and how, if it is a large spill, how the app will traverse through the data required. So here we see the code is split up into a couple different parts. Previously, we've seen the placard ID, the guide number, and the chemical name. But in addition to that, now we have night protection, day protection, and how far to isolate. And if we see here, there's a string that declares refer to table 3, which will then unleash some more data specific to that chemical. And each chemical entity within this specific sector are going to have their own details for protecting, regardless of day and night, the wind, and then any isolation distances that are needed. In addition, this is just one of the expansions that took place over the spring semester. We continue to add different chemical expansions, so making sure we're getting a large base of chemicals in there, along with guide pages, which are the orange pages that were previously referred to, and the green pages. So each one of these pages, seen a couple slides previously, all have key components in order for the app to work accordingly. In addition to expanding our back-end database, we had to continue forward in making sure that the connection between the back-end and the front-end remained persistent, as all this information we were now putting in needed to be able to be seen and represented by the end user. So in doing so, although we just have this plain screenshot here, the application will ask the end user various questions about the specific accidental scenario that they may be in the middle of. For example, if we were discussing the ammonia that was previously mentioned, then the application would ask them if it was day or night, how big the spill was, and if there was any wind present and how strong the wind would be. And all this information will be shown on the application itself. So that way all the necessary categories are being represented and being called on appropriately as the end user feeds the feedback into the application. Overall, we were able to achieve our ABO by automating the emergency response guide, so that way the app can improve first responders' response time to an accident that may occur whenever and wherever. This application will give all the important information for the incident to the end user, as it has a database of various placard and chemical information, along with functionalities to warn users of any hazards that could be present, and it'll display various first responder info that's needed from the emergency response guide in a timely manner. To end our presentation, we would like to give a special thank you to Bruce Torman, the technical director on this project, and all other RDSI staff who have been working with us, giving us feedback, which has all been greatly appreciated. We would also like to thank Dr. Sunak for being the program director of the ELECOMP Capstone program and letting us get this real-world experience, and our consulting technical director, Jamie.